Hello, and welcome to this short video on the GPX DDI module. The drug-drug interaction module in GPX enables true polypharmacy DDI predictions with no restrictions. That is, you can predict the co-administration of an unlimited amount of medications. The graphical user interface for the DDI module has been completely reimagined with a smooth, logical and efficient workflow that is in keeping with the new GPX user experience. You open the DDI module by clicking on DDI in the Modules pane on the right-hand side of the interface. Expand the configuration panel either by clicking on the green arrow or double-clicking anywhere in the panel header bar. From here, you can select the physiology schedule and the prediction type. When the prediction type is set to dynamic, the simulation mode becomes active and you can select single simulation or population simulation. The victims, perpetrators, run, and results panels are active whatever prediction type or simulation mode are selected. The perpetrator steady state concentration panel is only active when the prediction type is steady state. And the population settings panel is only active when the prediction type is dynamic and the simulation mode is population simulation. Let's first run a steady state DDI prediction. So we'd need to select the prediction type as steady state. We then expand the victims panel to select a victim compound. It is important to remember that for a compound to appear in the DDI module in either the victims or perpetrators panels, it must be part of a simulation, as a simulation contains the required assets of a compound, dosing schedule, and physiology schedule. In addition, only simulations with the same pharmacokinetic model as the physiology schedule selected in the configuration panel are displayed. So if the physiology schedule has no pair, so there's no population estimates for age-related physiology, then only compartmental PK models will be available. If there is a pair physiology selected within configuration, then only PBPK models will be available. Let's select one victim compound, in this case, midazolam. Please note that if a compound is in more than one simulation, then you can select a specific simulation via the simulation drop-down list selector. You can see here that midazolam is only in one simulation. In the fraction metabolized source column, you can select from the list options such as enzyme kinetics, user-defined, or predictions from ADMET predictor. You can also select in vitro if you have data from in vitro assays using either recombinant cytochrome P450 enzymes or human liver microsomes. Please see the DDI tutorials for more information on entering these in vitro data. You can either collapse the victims panel or scroll down the graphical user interface to the perpetrators panel. We then expand the perpetrators panel and select a compound. In this case, we will select ketoconazole. Once you've selected the inhibitor, the perpetrator, then make sure that you enter the interval in the perpetrator dosing and pharmacokinetic information table. You then scroll down and select a desired row in the perpetration parameters table, and then scroll down to open the perpetrator steady state concentration panel. Here you have the option to select from multiple calculated steady state concentrations or simulated concentrations. Here we will select simulated liver unbound. We would then continue to scroll down and open the run panel. You would then click on check warnings to assess any issues with the prediction setup. If a message appears in the message center at the top, then read it address any critical errors in the setup, and then click on Done. Now click on the Steady State Prediction button. When the Run Controls panel disappears, scroll down to the Results panel, which will automatically expand when the predictions have been made, and see the classification of the DDI predictions in the Steady State AUC ratios table. Color is used for easy identification of the magnitude of the drug-drug interaction. Yellow highlights a weak interaction, orange highlights a moderate interaction, and red highlights a strong interaction. So here we have a moderate interaction with the AUC ratios being 3.763. Now let's run a dynamic simulation. Scroll back up to the top of the DDI module and select the prediction type of dynamic. We will leave the simulation mode as single simulation. We will run a polypharmacy DDI prediction by selecting multiple victims and multiple perpetrators. So in the victims panel, we will select ketoconazole as well as midazolam. And in the perpetrators panel, we will select fluconazole as well as ketoconazole. Once we've selected all of our perpetrators, we would then need to select all of the constants required for the DDI prediction. So here we'll select 8.71 for fluconazole. It's good practice to click on the Check Warnings button, and if a message appears in the Messages Center, read it, address any critical errors in the setup, and then click on Done. So here we have a message highlighting that in vivo perpetration parameters have been selected for the DDI. So we will click on Done, and then click on Dynamic Baseline Simulation. When the Run Controls panel disappears, scroll down to the Results panel to look at the dynamic DDI calculated outputs for the baseline simulation. At this point, you can click on Analysis in the navigation pane to see the CP time view key view plot for the baseline simulation. Go back to DDI and then click on Dynamic Full Simulation in the Run panel. When the Run Controls panel disappears, scroll down to the Results panel and assess the DDI predictions of pharmacokinetic parameters and DDI ratios. So here for midazolam, we have a strong DDI with ratios of around about 15 for the AUC. For ketoconazole, there's a weak interaction with ratios of 1.31. You can again click on Analysis, and this time you will see the CP time key view plot for the dynamic simulation. Note that you can reselect the baseline simulation to show all of the plots together. It is possible to update the formatting of this plot, and I suggest you see other specific videos if you wish to do that. You can right-click on the plot and copy the image or the data and paste those in another application. Let's now look at a population simulation in DDI. So we go back to the DDI module, scroll up to the top of the DDI module, and then select Population Simulation as the simulation mode type. We would then scroll down to the Population Settings panel, which is now active. And here we can select the desired population size. So let's select 12 individuals. And we can also select the repeated trial size. We'll leave this at 1 for now. Scrolling further down, and we see the parameter table. So we could then update or amend those parameters if we wish. And then we go down to the Run panel and then click on the Run Population Simulation button. The Run Controls panel then appears to update you on the progress of the simulation. When the Run Controls panel disappears, scroll down to the Results panel. And here you can see the DDI predictions of pharmacokinetic parameters and DDI ratios. You would use the compound drop-down list selector to review the population predictions for each compound. So we'll select midazolam, And then within the table, there are detailed statistics for the mean, CV, min, max, geometric mean, and 90% confidence intervals calculated for the untransformed, as well as the log transformed data. Again, we have color coding of the rows, the ratio rows, to highlight the magnitude of the DDI. So a weak interaction is yellow, moderate interaction is orange, and a strong interaction is red. If we now click on Analysis in the navigation pane, after running a population simulation with the DDI module, then the view will be the population view in Analysis. Once the population view appears, then via the simulation list, select which trials you wish to plot. And then within the population view, select which compound. Within the analysis view, you can switch the mode to the summary view to see the prediction of parameters and statistics for the individual subjects. You can apply the filter to focus on one particular compound. And you can also set the observed data on toggle to off to view all of the predicted parameters without having to scroll across the graphical user interface. If we open up the statistics panel underneath, you should be mindful of the fact that the statistics will not be separated by baseline and DDI. So if you selected both of the runs as we have here, so the baseline and the full interaction, then all of the statistics will reflect the combined trial, not the individual trial. Within analysis, you can also switch to the key view. And here you will see the CP time plot in the key view showing the simulated CP time profiles for all of the subjects for all of the compounds. You can expand the additional features panel, select color by random, and then click on color by to update the formatting of the plot. One other key point to remember is that for population simulations, files are automatically created for both the baseline and the full simulations, and they're saved in the folders within the folder containing the GPX project. One other key point is DDI predictions require that all of the compounds are part of the same GPX project, and the asset export import functionality makes it very easy to merge compounds from different projects. For example, let's go to the dashboard view and then open the project gas DDI standards. And then on the dashboard view, once the project is open, you would need to select the export option. From the drop-down in the middle, select simulation, and then navigate to the quinidine compartmental PK simulation. Enter a project name, so we'll enter a name, quinidine compound PK export, and then browse to a project location, and then finally click on export. Once the export has completed, click on OK. And now we need to select the project to which we want to add the quinidine compartmental PK simulation. So we go to select and then browse. So we'll go back to our original project, select that project. Once that project is open, click on import, select simulation, browse to the project that we want to import. So that is the quinidine compartmental PK export. Click on Open. Check the Import All toggle is on, and then click on Import. Once the import is complete, click on OK, and then simply go to the DDI module. And then with the DDI module, open the perpetrators panel to see that quinidine is available for selection. That brings us to the end of this presentation. Thank you for your attention. If you'd like more information, then please visit our website at www.simulations-plus.com or email us. Thank you, and I look forward to hearing from you soon.